All right. Hello, guys. Thanks for coming to my talk. This will be a lightning talk with a little bit of storytelling. So mostly it will be technical, but there will be 3 tips from my side that I use as well in my daily life. So atomic habits for the cost optimization in the cloud. I'm Bartosz Wieczorek. Principal software architect at Sabre, and I'm responsible for big data applications performance, cloud cost reduction, cloud architecture, and I'm also a conference speaker. So you can find me on LinkedIn, on GitHub, or just ping me after the talk. So what is the agenda? Agenda is about atomic habits. Maybe you know that story. Maybe some of you don't. It's about also to give you the context for atomic habits and our changes that we made to improve our software and reduce cloud cost. It was about Sabre, one specific big Sabre project that we achieved lots of optimization. So I'll give you the context, what is it about. And I will give you 5 tips to optimize the cost in the cloud. Before this meeting, I had a compiled list of 20 optimizations, so I needed to make a trade-off which one would be the most interesting and which one would be the easiest one for you to implement. So hopefully I did some good job and you will be able to remember some of those. So what is Atomic Habits? So Atomic Habits is the title of the book, which I really recommend you reading, but I will summarize it a little bit. So imagine a group of cyclists, a British cyclist team, who performed so poorly during the competitions that the bike manufacturer didn't want to rent them bikes because of the fear of the bike's sales drop because of negative association. But luckily that team got a new trainer with a revolutionary technique called Atomic Habits that is about changing one tiny thing per day. So small daily improvements. And what this team really did is that the first day they redesigned the bicycle saddles to make it more comfortable. Another day they took care of better food. The next day they concentrated on a little bit longer, more relaxing sleep. The next day they changed their sports clothes to be better in terms of keeping muscles temperature. They also tested different gels for muscle regeneration. So after these small daily improvements, after 6 years of applying those, they took care in. They participated in the Olympic Games in Beijing in 2008, and they scored 60% of the medals in bicycle, road, and track cycling. And after 4 years after that, in 2012 in London, they actually set 9 Olympic records and 6 world records. So I encourage you to also have some atomic habits in your daily and professional life. For example, my atomic habits in professional life is breathing technique from Wim Hof, which will energize your body instead of yet another coffee. Or doing some Jacobson meditation as a relaxation before going to sleep. Or just being friendly to the world because the people will be also friendly to you. So there are many techniques that you can try for yourself and for the professional life that will definitely pay off. And today I'll be now discussing a little bit the technical stuff. So the story I want to share with you is how we saved 45% on the cloud cost which in case of one specific Sabre project ended up with a saving about $900,000 per year. So if you stay with me, I will show you what are the ways to achieve that money, maybe at a different scale in your organization. So let me walk you through a little bit of a use case so you know how to compare this amount of money and map it to your case. So for one of our cloud projects, which is a GCP project, the project is called Air Shopping. We ingest, so we bring in a lot of data into our data lake. And we have our jobs that bring the data that run every 30 minutes, and at peak they ingest 700 GB of compressed data. So if you uncompress the data, it would be even terabytes of data brought like every hour. And we utilize GCP virtual machines auto-scaling to adjust the demand for the peak and the lower traffic. We store the data in BigQuery using all possible number of partition, which is 4,000. And essentially, we have right now in the table 12 petabytes of data and 127 billion of rows. So it's a massive amount of data just for the single project. So as you know the context, I will share with you the first tip. This will be really obvious tip, but without that you cannot really go much into the cloud optimization. Try to build a dashboard that will tell you what is the cost of each resource in the cloud that you use, with the breakdown of technology, with the breakdown of environment. And use labels to really filter down which resource you want to optimize. So this is really like straightforward, but it's important to do it right and calculate it right, because you will be making technical and business decisions after that. Tip number 2. So how to find the best performing virtual machines. If I look in the Google documentation, there will be at least like dozens of machines. So which one to choose actually? Shall I test each individual machines, or shall I kind of categorize those machines? And think of that as Google says in their docs, try to categorize them with everyday low-cost category that will make your job done. So think of a Dacia car as example to get you from place A to B at the lower cost, which is a budget approach. Think of the regular approach, which could be compared to the Toyota car, for example, which would be the T2D standard 4 machine. And really like really CPU optimized, very fast car, BMW, which is analogy for having the machine which will do the computation really fast for you. So which one is a winner? Is the BMW the fastest and solve all the problems? It's not always the case. Like the fastest is the best one. So how to approach choosing the best machine? You can see 2 links, and for each cloud vendor there will be such links. So like first link, the blue link, will tell you which machine is really the fastest, which machine has the best benchmark. So to represent it on the graph, if you look at the blue bar, the first category machine, E2 standard 8 machine, can do the job in 1 unit of time, right? And if you look into the second category, T2 standard 4 machine, it can do the same work 12% faster. And if you look in this BMW machine, which is C2D standard 8 machine, it can do the job even 33% faster. But speed is one thing, but we also pay for the machine. And if you compare T2D standard machine, the cost of that is, if you look at the blue bar, in the green bars, now 63%. it's the cost for the regular machine, a standard machine. And if you look for the C2D standard 8 machine, it's a little bit more expensive. So actually, to solve the problem, you need to multiply the speed, so the execution time, times the cost for each machine to accomplish that task. And if you do the multiplication, you will see the normalized result, which will tell that T2D standard 4 is the winner. So the multiplication has the lowest value. And C2D BMW is very close to that. And T2D standard 4 machine is well known for the best performance per dollar. And you can read more on that. So to summarize, maybe try with T2D standard machine if your use case is really CPU intensive operations. In our case, it was parsing XML, lots of CPU bound operation there, so it was our saving. And actually that saving allowed us, and that was a single line change in our machine type deployment that gave us hundreds of thousands of dollars per savings per year. The third tip. There was one guy last year who came to me after GeeCON presentation that was really inspiring for me. That's why I put this slide, and thank you for that. Challenge the defaults. What I mean by that, for example, Google is really great in finding the solutions for every customer to work. If the customer complains that certain corner case doesn't work, Google quickly creates a new, better version of a product that will solve the problem. And they are really great in doing that. But that comes with additional cost. So I encourage you to look a little bit what is the problem that you're having. Do you need to choose really the most expensive solution? Or maybe sometimes it's worth to investigate for a couple of days and not go for the most expensive one, but fine-tune the existing solution. And here is two examples for that. The regular bucket creation is with the global replication. And do you really need that global replication for every your use case? Imagine you've got lots of small files, and you have one job that writes the data to the bucket, and another job quickly reads the data from that bucket, and you're done. So essentially, when choosing the regional bucket, if it matches your expectation, you can achieve much better read throughput and much better write throughput. Another example is about data shuffling. So sometimes when your application is deployed on multiple nodes, on multiple VMs, and each of these VMs cooperate with each other, you are doing some group by key operation, either explicitly or implicitly. What it means is that if one machine has different keys, and another machine has different keys, and a third machine has different keys, you eventually want each machine to contain the same keys. So if you look into my example, the first VM has different keys, the second and third one, but at the end of the day, you want one machine to have only key 1, and you don't want to have key 2 to be on a different machines. So there are different ways to do it in data flow. You can do Google recommended external service called data shuffling, but it comes with additional pricing cost for each gigabyte you are sending in and out to that service. And that's expensive. It was expensive for our case. So what we did actually, we evaluated how much SSDs we need to be attached to each individual VM to make that shuffling happening not via external service, but on that SSD associated to the to that VM. And by doing that, in our case, we were able to significantly reduce the cost compared to the external service. And external service was the default one for data flow batch. And another use case, that's still maybe a trivial case, but if your application is optimized for processing, it doesn't have any hot areas. It's cheaper in the cloud, right? So you can try to use Java micro benchmark harness, which is a great tool. Essentially, you write one class, you annotate your method that you want to test method 1, and you annotate method B with at benchmark annotation. And eventually, after 10 minutes from running on your laptop, you will see that, for example, parsing JSON with a method that accepts string builder, it's 3 times faster than parsing JSON using a method that accepts a string. So quick, really way to validate which solution to choose from the market, because there are dozens of libraries to parse JSON. Once you deploy your application to GCP, you can also use the GCP profiler, which will tell you where your application spends most of the time. And that slide shows the case where we had a bug in our application because we were looking, we were doing lookup if the list contains a certain restricted element. And that was working fine if we had like 1,000 of elements in the list. But during the night, one day, the list was refreshed and we had like almost 1 million of elements, and that lookup against the list was extremely inefficient. And by changing that lookup against the hashed collection, it was instantaneous, and that was really fast. Such obvious things, and Profiler was able to show us where the problem was. And the 5th tip for today, it's a little bit about re-architecting. Since I'm also the architect, we always look what are the legacy on-premise solutions that we use, that we pay licensing for. We need to pay the license for Oracle ODS, for Teradata, for Vertica, for Hadoop. And after migration to GCP, we were able to use the GCP native stack to achieve the same backend processing. Of course, this is not the visualization part, which includes Looker, but think of that if you go for a cloud native solution, some of the legacy proprietary software may go away and reduce the cloud cost. I think I'm almost done with my presentation. If you're interested in some code level examples, how we achieved optimization, have a look in the previous year GeeCON. My presentation, have a look also in the JDD, how we migrated the architecture, what challenges we had in data flow, and how we resolved them with the great cooperation with Google engineers. So once again, thank you for your presence, and I'll be happy to take any questions or come to me, because it will help me to improve my presentation in the future, and hopefully I will see some of you here next year in upcoming years. Guys, good luck and have a great day. Thank you. Okay, I think there are no questions, so thank you guys, enjoy your day.